algebra. What is it good for? Not absolutely nothing. A lot of things. Algebra is pretty cool, actually. What is this algebra thing you're talking about, though? Algebra was a mathematical invention to solve problems using letters or symbols to represent unknown quantities. It's pretty cool, and it's kind of like being a math detective. Why do I need to learn algebra? Well, learning how to use algebra is unlocking a new part of your brain that changes or can create new pathways for thinking. It can help you solve problems and understand the world around you in a different way. It's an awesome tool for business, for science, for tracking data, and for finding out the unknown. So today what we're going to do is we're going to get into the introduction for algebra and learn how to use this tool to help us solve problems. I need a pen. Here we go. So first thing I'm going to do is I'm going to put an equation up here and I'm going to use a letter in that. So don't freak out. Now here I've got this equation up here, 12p minus 3 equals 33. And the first thing we need to do is we need to identify some vocabulary that's used in algebra to help us know what we're talking about so we can communicate in the same way. I didn't like my shadow. So the first thing I want to show you is everything on these two sides of the equation are called terms. Okay? And these terms, it's important that we identify them as terms for when we get moving into the next level. So I've got terms over here and terms over here, and there's something in between those two terms. And you'll notice that that is my equal sign here. And my equal sign is like it's like a scale or a balance or the tip of a teeter-totter, and it's perfectly the same on both sides. They are equal. This term is equal to this term. And that's really important to hold on to when we get to inverse operations. I need to keep my terms in mind. So here I've got a term and I've got a term. Now you notice here I've got a letter. And this letter, I don't know what it is yet. This letter, we're going to call it a variable. And a variable means an unknown. So this is what we do not know. We got a term, and they're equal, and there's some type of variable here. So we need to be consistent with those. And there's one other thing I want to point out here. This 12 is pretty important here. First of all, there's no math operation being shown in between the 12 and the p. But it means I have 12 of this p. And when you see the word of in math, it should help you usually think that this is multiplication. And when I get into algebra, that's when math starts using this dot for multiplication, because if I put an x there, like we do in the younger grades for multiplication, that could get confusing because I'm using letters now, so is x multiplication or is x a variable? So we're not going to use x for multiplication anymore. We've got to use this dot. So I've got 12 times p minus 3 equals 33. All right, so we're going to stop right there and go back to this 12. This 12 is called a coefficient. Oh goodness, I hope I spelled that right. I'll check that later and I'll put the correct spelling on the bottom of the screen. So I've got 12 times p minus 3 equals 33. I've got a variable in my letter, an unknown. I've got a coefficient in front. That's a coefficient's almost like an adjective or adverb. It's like modifying the variable. It's telling me how many of those groups of variables I have. So I've got 12 times P minus 3 equals 33. All right, now I'm going to erase some of these details as we move in to other steps in algebra. Now, some of you guys have great number sense and you're sitting there at home and you're like, okay, well, I could guess this. I could pick a number and plug it in for P and see if it's correct. And if I'm on a multiple choice test, there's no reason why that's not a good strategy. I can say, okay, what if P was 5? If P was 5, 5 times 12 would be 60. 60 minus 3 would be 57. 57 is not, in this universe, equal to 33. I mean, what if it was? Then when I was 33, I'd be 57, and I got old fast. So 5 was not my answer, though. But you could plug numbers in. But what if I don't want to spend all day guessing? Can you imagine if that's the way we tried to solve problems as adults? If instead of using clues and formulas and following different steps to get to a solution, if like police officers were like, I'm going to go knock on a random door and see if that's where the person is that I'm looking for. Or I'm going to stop a random car and see if that car has the person I'm looking for in it. If that's your strategy, you could be at this all day. Because once you get past 6th grade stuff, you're not going to be getting whole numbers for your variables. It might be some fraction or decimal or exponentially large number, and I got to be able to find that without just guessing. So we're going to move into the next level. Now that we've identified what a variable is, what a coefficient is, and what terms are, and that these things are equal, how do we solve this? Let's check this out. I'm going to erase some of these things that I wrote on here, but I'm going to keep the equation up. All right. And I'll erase this. For now, I'm going to leave the multiplication sign between the 12 and the P just to help you remember that that is multiplication. So a strategy to solve this is inverse operation. Now let's break down what the word inverse means. The root verse here means a line. So let's say if I was like in a play, I'm up on stage doing Romeo and Juliet, Shakespeare's Romeo and Juliet, and I say my line, I'm saying my verse. If I was writing a song that I was going to sing, I'm like, I grab my mic and I'm like, I gotta sing this verse. I'm singing a verse. I'm singing a line in the song. Well, in mathematics, these are my lines. Okay? They're the terms. This is a line and this is a line. And the line tells me that I have to use order of operations and I have to multiply 12 and P and then subtract 3. Whoa, my voice went out. In this line. So that's what's happening in this line. Now the prefix in, if I'm really good at my vocab skills, I know that in means not or the opposite, right? So inverse means I'm going to do the opposite of whatever this line wanted me to do. So the first thing I'm going to say is, I want to get P all by itself. Like that's my goal. At the end here, I want to know what just P equals. P with no coefficient, P with no adding or subtracting, nothing else going on. I just want to know what that letter P is going to stand for. Well, the first thing I can do here is I'm going to move this 3 out of the way. All right? So I want you to start thinking, I'm subtracting 3 there. What could the opposite of subtracting 3 be? This math lesson is unofficially brought to you by Mountain Dew Kickstart. Hopefully you thought of this great idea like, well, the opposite of subtracting 3, Mr. Orton, is adding 3. So I'm going to add 3 to this side. If I had any number in the world, let's say I have 20 bucks in my pocket and I take $3 of that $20 and I give it to Billy down the street. I'm like, Billy, here's $3. And Sam, on the way home, stops me and goes, hey, Mr. Horton, here's $3. I started with 20. I gave 3 away. I got 3 back. I'm back at 20. It doesn't matter how much money I start with. If I take something away and add that same amount back, I'm back to the beginning. So if I was going to subtract 3, but then add 3, I don't need to do either of those things. These would cancel out. However, I have to be thinking about this equal sign. They're in balance. So if I'm going to add 3 to this side, what do you think I have to do to this other side? That's right. I've got to add 3 to that side also. So now, subtract 3, add 3. These just kind of go away. They cancel each other out because they're the inverse operations. Well, now I got 33 and I'm going to add 3. Let's just go ahead and make an adjustment here. 33 plus 3 equals 36. So now my equation here, and I still want to get P by itself, tells me that 12 times P equals 36. Now some of you are really like, dude, I could just guess now. I got the guess. While the guessing is awesome, let's think about the strategy and how I can actually solve this problem using inverse operations and algebra. Well, I need to think, what's the opposite of multiplying? 3, 2, 1. Yeah, that's right. The opposite of multiplying is dividing. So instead of multiplying by 12, I'm going to divide by 12. And if you followed any of my lessons before, I'm telling you that the division sign means fractions. And this is going to be the numerator. I'm just going to draw a line like this and write 12 underneath. Now, just like when I gave $3 to Billy and Sam gave me $3 and I started back at the beginning, if I have something and I multiply it by 12 and then divide it by 12, where do I end up? I'll give you an example. What's a really easy example? How about 1? How about 1 times 12 would be 12, divided by 12 would give me back to 1. 12 divided by 12 is 12. Okay, we should check it with another number in case it's only 1. What if I took 2 times 12? That'd be 24. 24 divided by 12 gets me right back to 2 again. So I am using math to prove that what's going to happen here is these aren't going to matter anymore. Because whatever I multiply by 12 and then divide by 12 is going to give me right back to the beginning of my variable I started with. But wait, there's more. I can't miss this. This is really important. I can't just divide by 12 on this side without doing something to this side. Remember, they have to stay in balance. So if I divided this side by 12, what do you think I have to do to this side over the 36? That's right. I got to divide this side by 12 also. So now I've got 36 divided by 12. Well, how many times can 12 go into 36? 12, 24, 36, bam, 3 times. 36 divided by 12 is 3. So I can rewrite this as 3 on this side. This on this side becomes P. P is now all by itself, and P equals 3. Don't believe me? Let's go back to the beginning and try it. Let's see if this is correct. All the way back at the beginning, I have 12 times P minus 3 equals 33. By the way, when you're just getting started on this, you should always go back to the beginning and plug your numbers in and try it out. So we are going to say, what if P is 3? Was I correct? That means 12 times 3 minus 3 equals 33. Make sure you're following the order of operations, okay? I need to multiply before I subtract. So I multiply 12 times 3, and that would give me 36 minus 3 equals 33. Is 36 minus 3 33? In this world, yeah. Probably in other worlds too. Prove me wrong. I would love to hear your argument. That sounds rad. Okay, so we've taken a look at algebra and inverse operations. What's a variable? It's a letter that represents an unknown quantity. What's a coefficient? It's the number that's in front of a variable that's telling you how many of that value you have. What's a term? Terms are on the separate sides of the equation, and the terms have to maintain balance with that equal sign. That's all algebra is, guys. So let's try a couple real quick. This would be a great time to have a piece of paper out. I mean, every time in math is, and a pencil. And I want you to write down this problem, and I want you to try to follow along with me and do it yourself. And if you're really fast, see if you can get to the correct answer before I can. So here we go. Let's get a problem here, and I'm going to say, let's go with 6x. I want you to get used to solving for that x. 6x equals 18. Okay, don't get the answer by just guessing. What is the inverse operation? Well, 6 times x equals 18. I would want to divide by my coefficient on both sides. X times 6 divided by 6. I don't need to do that. X is by itself. X is 18 divided by 6. 18 divided by 6 is 3. Oh man, shoot. I made up a problem on the fly and the answer was 3 again. Promise you guys, I promise you. Where is my camera here? I promise you every answer is not 3. I promise you. Okay, I'm going to make sure the answer is not 3 on this next one. Let's get even simpler. The simplest version of this. X plus 2 equals 7. I have something plus 2 equals 7. Well, you've really been doing this your whole life. It just probably said blank plus 2 is 7, and we replaced that blank with an x. So something plus 2 is 7. We know what that is. That's 5. How do I prove it with inverse operations? Well, remember, I've got to keep this in balance. I want to do the opposite of adding 2, which is subtracting 2. And I have to do this to both sides to keep it in balance. 7 minus 2 is 5. Plus 2 minus 2. Don't need to do that. I'm left with x equals 5. Whew, it's not 3. I'm super stoked it's not 3. So this is a simple walkthrough of order of operations. Let's see if you can do this one on your own. 2, let's think of a letter, R, equals 14. So something times 2 is going to equal 14. Now, these are still ones that a lot of you guys can guess on, but I want you to think about how would I do this as an opposite. 2 times R equals 14. I want to divide both sides by something. Go ahead and yell it out loud in your house. Awesome. 2 is the correct answer. If you didn't yell 2, you should have yelled 2. These 2's are going to cross out. 14 divided by 2 is going to equal 7. On this problem, R would equal 7. That's about 6th grade algebra. Now, we could keep going and look at different equations. Let me see if I can stump you on this one. What if I have division in my problem? What if I have x divided by 3 equals 12? Something divided by 3 equals 12. Well, the opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. The opposite of division, therefore, is multiplication. I'm going to multiply by 3. And notice I wrote 3 over 1. And that's because I feel like you should be comfortable multiplying fractions at this point. And this really helps me out. I forgot something. I got to do it to both sides, right? Remember, this has to stay in balance right here. So I have to multiply this side by 3 also. Now, why did I not write 3 over 1 over here? Because I didn't have a division problem or a fraction on this side already. 12 times 3 is going to be 36. Now here, I'm going to rewrite this as 3x over 3. Remember, I multiply across on the top and the bottom. If I have anything times 3 divided by 3, my 3's can go away, and I'm left with just x. X equals 36. I'm still in balance. I gotta stay in balance, my friends. I gotta stay in balance. Is 36 divided by 3 12? Yes, it is. And my inverse operations proved it. All right, see if you can do this on your own now. Intro to algebra. Ready, set.